Hello everybody, we are discussing about the signals and systems. In that Fourier series already we have completed. Now we will see some gate questions based upon the Fourier series. And this is a gate question for EC people which came in the 1987, 2 marks question. Okay, half-wave rectified sinusoidal waveform has a peak value of 10 volts. Its average value and the peak value of the fundamental components are respectively given by. Okay, so half-wave rectified signal means already you know. This is the sine wave. Half-wave rectified means it is like this. Full wave rectified means it is like this. If you observe, the cycles will be repeating right and left side. So it is a periodic signal. It is also a periodic signal. So we can apply Fourier series. So it is having some DC term A0 and some AC terms will also be available like cosine terms and sine terms and the second one also. Okay. So what is the thing means here? Half-wave rectified signal. What is the DC value of that one? That one only they have asked. So in the peak value they have given. That is, for example, if you take that peak value Vm is equal to 10 volts. The signal is this one. This is the peak value 10 volts. You need to find average value or DC value of the signal. It is given by Vm by pi. That means 10 by pi. So 10 by pi is available in the options B and C. And next RMS value of the, peak value of the fundamental component. That means if you see the expression for this one, it may have omega naught term and 2 omega naught term and 3 omega naught term like that. So many terms will be available. These are the integer multiples of the fundamental frequency, but they are asking the fundamental frequency component of the peak value. That means the term which is involving omega naught, the term you need to take its peak value is required. That is given by Vm by 2. That is nothing but Vm is 10 by 2 means 5. So option C is the correct one. That means option B is wrong one. So option C is the correct one. So option C is correct one. Next. This is a gate question, came in 1993, 2 marks question. The Fourier series of the periodic function whose period is 2 pi defined by f of x is equal to 0, that is from minus pi to 0, and f of x is equal to x only when x is changing from 0 to pi. This one I will draw first. So that means independent variable is x and dependent variable here it is represented with f of x. When the signal is the independent variable x is changing from minus pi to 0, the amplitude is 0. When independent variable x is changing from 0 to pi, the amplitude is x only. That means how x is changing, in the same manner f of x is also changing. So here also pi is there. 0 to pi x is changing, 0 to pi amplitude is changing. So this is one period. That means what is the time period of the signal f of x? 2 pi. Already they have mentioned here. Capital T is equal to 2 pi. Capital T is equal to 2 pi and omega naught means 2 pi by capital T, that is 2 pi by T means 1 radian per second we will get. Okay. Then the Fourier series expansion of this particular signal is given already. This is the Fourier series expansion, that is pi by 4 plus sigma n is changing from 1 to infinity 1 by pi n square into cos of n pi minus 1 into cos nx minus cos n pi into sin nx. This is the, here 1 by n is also, this is the Fourier series expansion already they have given. By putting x is equal to pi in the above expression, one can deduce that the sum of the series. What they are telling, they have given one periodic signal they have given. This is during one period how the signal is changing, it will be repeating. This particular pattern is repeating. Okay, that is the periodic signal and its Fourier series is also given. With this given information, we need to find 1 plus 1 by 3 square plus 1 by 5 square plus 1 by 7 square and so on. The summation value we need to find. This is the gate question. Okay, the question is based upon the Fourier series. They have given what is the periodic signal and they have also given the Fourier series expansion. With this given data, we need to find this summation value. Okay, finally we need to find what is the value of 1 plus 1 by 3 square plus 1 by 5 square plus 1 by 7 square and so on. This is the thing. Okay, so in this expression, what we need to find, what we need to substitute means x is equal to pi. this entire thing is equal to f of x only. So f of x is equal to this entire thing has to be substituted. Okay, so x is equal to pi means x of pi. X of pi is equal to how much? If you see this graph, x of pi, that means whenever x is equal to pi, what is the value? This is not pi. Okay, if you simply take pi, the answer is wrong. Okay, why it is wrong? In the sense here discontinuity is there. So whenever discontinuity is there, from the starting onwards I have told, the amplitude is average value of the previous value in the after value of that particular discontinuity. That means from where to where the amplitude is changing, that you need to identify. That is from pi to 0. Okay, exactly at x is equal to pi, what is happening? The amplitude is changing from pi to 0. So the average value of these two you need to take, that is pi plus 0 by 2. That is pi by 2 is the value of the f of x at x is equal to pi. So f of pi is equal to pi by 4 plus sigma n is changing from 1 to infinity 1 by pi n square into cos n pi minus 1 cos n pi, x is equal to pi, I am substituting, minus 1 by n cos n pi sin n pi. Sin n pi is 0. Okay, for all values of n, sin n pi is 0. 0 into this entire thing is 0. So up to here I have substituted. What is f of pi? Just now I have explained, that is average value of pi and 0, that is pi by 2. Pi by 2 minus pi by 4. This pi by 4 I have sent this side. So it is equal to, now sigma n is from 1 to infinity. This 1 by pi I am writing outside, 1 by pi, 1 by n square I am writing here. Next, cos n pi. Cos n pi, in the previous classes I have mentioned that it is minus 1 whole to the power of n, minus 1, cos n pi is again minus 1 whole to the power of n. Okay, pi by 2 minus pi by 4 is how much? Pi by 4 only. This pi, if you send this side, you will get pi square by 4. It is equal to, if you take n is equal to 1, what will happen? Minus 1 whole to the power of 1. That means minus 1 minus 1 minus 2. That means you are getting the number. But if you take n is equal to 2, minus 1 whole to the power of 2 is plus 1 minus 1. If you take n is equal to 4, minus 1 whole to the power of 4 is plus 1 minus 1. Again it will become 0. That means for even n, the answer is 0. But if you take odd n, answer is some number you are getting. So if you take n is equal to odd number, what will happen? This minus 1 will be minus 1 only. Minus 1 minus 1 will be minus 2. And it is also minus 1. That means up to here you are getting plus 2. Okay, so plus 2, this plus 2 if you send this side, it will come in the denominator, and here what is the remaining thing? Simply sigma n is from 1 to infinity 1 by n square, but n value odd value only you have to take. That means n is equal to 1, n is equal to 3, 1 by 3 square, n is equal to 5, 1 by 5 square, n is equal to 7, 1 by 7 square, and up to so on. So this entire right side sequence is equal to pi square by 8. That is the answer. Pi square by 8 is the answer. Next gate question is, it is from 1999, 2 marks question only. Fourier series representation of the impulse train signal given by. So impulse train signal already we have done from our starting classes of the Fourier series only. So here I am not doing that one. The answer is 1 by t. Sorry, it is, they are asking Fourier series representation. What is 1 by t? It is the Fourier series coefficient. So if you have Fourier series coefficient, it is easy to write Fourier series expression also. That is s of t is equal to sigma n is from minus infinity to plus infinity cn e power jn omega naught into t. So cn already we know, that is 1 by t. So 1 by t I am writing outside because that is independent of n. So 1 by t sigma n is from minus infinity to plus infinity e power jn omega naught t. So this is the exponential Fourier series representation of the impulse train signal. Now one period 0 to t, each of the two periodic waveforms W1 and W2 are shown in figure. So two waveforms they have given, and they have mentioned these are the two periodic waveforms. One is W1 and second one is the W2, and the representations they have given only for one period, that is from 0 to t. So 0 to t, the waveform 1 is available like this, and from 0 to t the waveform 2 is available like this. Okay, and these waveforms are continuing like this. This pattern is continuing like this because these are the periodic signals. Okay, next the magnitudes of the nth Fourier series coefficients of the waveform 1 and waveform 2 for n is greater than or equal to 1. N is odd or respectively proportional to. Already this type of things already we have done. So here amplitude is, we can take t power 0, t power 0. Here amplitudes are varying with respect to t power 1. That means ramp is there, that's why t will come. Here constant is there, that's why t power 0 is there. For this the Cn is proportional to 1 by n. Magnitude of n also we can take, or here Cn is proportional to 1 by n square, because here power 1 is there, here square will come, here power 0 is there, here power 1 will come. So what are the answers now? Here power in terms of minus they have given, so option C is the correct one, because magnitude of n whole power minus 1, magnitude of n whole power minus 2. So answer is C. Next one, which of the following cannot be the Fourier series expansion of the Fourier periodic signal? So this is from GATE 2002 1 mark question. So what are the conditions we have to check? Whether the omega naught values are integer multiples of the fundamental frequency or not. Here 1 is there, 1 into t, here 3 into t. So it is surely the periodic signal only, and it is the Fourier series expansion. Here pi is there, here 1 is there. So here only we can tell it is not a Fourier series expansion. So option is B only. DC term, cos term, it is also valid. And here 1.5 into pi t, here 3.5 into pi t. So I think 0.5 into pi we can take omega naught, and it is a multiple of 3 and it is a multiple of 7. Like that we can able to take. So it is also Fourier series only. So option is B, that is not the Fourier series. Next, let x of t be the continuous time periodic signal with the fundamental time period capital T is equal to 1 second they have given. This is 1 second. Next, let AK be the complex Fourier series coefficients of x of t, where k is the integer value. Generally we will represent with Cn. Here they have represented with AK, anything is no problem. Consider the following statements about the x of 3t. So it is like time scaling property. So first I will tell about the time scaling property. X of t is having the coefficient is Cn, and it is having the time period is t, and it is having the frequency is omega naught. What about x of at? X of at means it is also having the coefficient is Cn only, but its time period is t by a, and its omega and its fundamental frequency is a into omega naught. These are the things we have to consider. Now see the statements. The Fourier series coefficient, the complex Fourier series coefficient of x of 3t are ak. So it is okay. Okay. First of all, x of t is having ak, and x of 3t is also having ak. So first one is correct. The complex Fourier series coefficient of x of 3t are 3 into ak. So second one is wrong. Third one, the fundamental angular frequency of x of 3t is 6 pi. That means actually what we have now, the fundamental frequency of the original signal is to be multiplied with the scale factor. Here scale factor is 3. So 3 into, okay, here they have given time period is 1 second. That means it is having the fundamental frequency is 2 pi by capital T. That means fundamental frequency is 2 pi. It has to be multiplied with the scale factor 3. That means 2 pi into 3 means 6 pi. So it is also correct. So 1 and 3 are correct. That means option B is the correct one. Thank you. With this we have completed the Fourier series, including the gate questions.